Hi all you Mojotonians, welcome back. Part 2 of our wiring of our 5E3 Tweed Deluxe kit. Okay, so in the last video we got our board wired up, as we can see. There we go, looking pretty, looks good. Bunch of wires going on there. And I got the back side clipped off, so there's nothing shorting or touching each other that shouldn't be. Okay, so I'm going to set this to the side for now. And the next step is to actually do our transformer wiring on our power transformer and our output transformer. Now, if you notice down here, I've left off the jacks, the 4 input jacks and the 2 output jacks for this. I've left that off, and the actual cord, I've left that off as well because it just gets in the way. It's much easier to do the jacks outside of the chassis, and I will show you why that is once we get everything together. You'll see it's a super tight fit in there, and to be able to, you know, to solder the actual resistors on the bottom of the jacks themselves is kind of a pain. So I like to do that outside, and it gives more clearance to the board when we set the board in here. So on our physical chassis wire, what I'm going to start with is the actual power transformer wires. And like I said before, I believe it might have been in the first or second video I did, I was explaining the primaries and secondaries. We're actually using a export transformer now that has a, let's see here, it has a 100, 120, which is your white, black is your start. Okay, so we have 120, I don't remember the color, I believe it's 100, red and black, 220 blue and black, I believe, and then 230, 240. But I can't remember off the top of my head. But anyway, regardless, we're only going to be concerned with the 120 volt primary here in the States. These I'm going to cut off and tuck down into the chassis. Leave a little bit of room in there in case, you know, you ever want to sell it or something overseas to somebody, like I explained before. You can, you know, you have enough lead there to change the voltages on. And what we're going to do for all the AC wiring in this, including the filament wiring, which is the last wiring I'm going to be doing with this, we like to twist the match pairs. Okay. Now the reason we do this is that Fender learned real early on to eliminate noise, especially in circuits that didn't have grounds, to twist the wiring like this. If you have 2 wires of the same coil and a secondary and even a primary together, what happens is that you could create capacitance and you actually create a field around the wire when the 2 wires are laid directly next to each other. However, to mitigate any kind of noise or hum issues for that, what we need to do is concentrate the field to the wire itself, and when we twist it, it does exactly that. So that's why you see you know, a lot of ham radio and hi-fi guys, and actually pretty much all amps that have leads in them. The AC secondaries and primaries are always twisted like this. Now I like to do, you don't have to be like super tight. Do about 2 turns per inch maybe, which is about like what I'm doing here. So we have our high voltage secondary, which are the reds. We have our filament 6.3 secondary for our 6V6s and our preamp tubes right here. And then we have our filament for the rectifier, a 5Y3 right here, which is 5 volts. Alright, so I'm going to twist these up. And these leads are going to be pretty short because in the most Tweeds, the transformer wires don't go very far, maybe I think 4 to 6 inches max, you know, depending on the amp. So we give you plenty of lead here to work with. And our primary here, black, which is a start. If you happen to look on the website at the Mojo 760EX transformer, actually all of our transformers, we have wiring diagrams on there. You'll see that for the most part, starts on a transformer primary will be black. Fender, or excuse me, I think Marshall had some different things, but Fender is always black. And people, a very common question I get on these when people are putting them together is like, well, to keep the code, the white needs to go with the neutral on the switch, and the black needs to go to the fuse on the actual fuse, or excuse me, with the line voltage on the fuse holder. And you know, that's not entirely correct, because a lot of companies now, especially if this was a domestic transformer, and like what they used to do, and still some companies do this just for particular transformers, they'll only have 2 leads on the primary of the transformer, and if it's not fused, it doesn't matter where these wires go. So think of these as just two black wires. You don't know which one's going to the fuse and which one's going to the switch. Now, for consistency's sake, yeah, I recommend putting the white wire with the switch, because the white from the your outlet, your 3 conductor core coming in, the white will go to the switch and the black to the actual fuse. That does matter. The wires coming from the 120 volt from your wall does matter where it goes in the actual amp. You always want your black on your fuse and your white on your switch. The reason being is that your black carries your live voltage, your 120. In most cases, most homes, your white's your neutral, which doesn't really carry voltage in most circumstances, but there's an exception to every rule. So what will happen is, if you put the white on the fuse and you accidentally blew the fuse, well, you've got your black going through your switch. And if your switch is on, guess what? You have line voltage and ground going all through this back to the fuse holder, back through the neutral line. So even though you blew your fuse, you still have an energized circuit somewhat. That's why I like to put the black, especially for the black on the actual cord going to the fuse, because if you blow the fuse right here, guess what? It cuts out all that line voltage for the rest of the amp right here. That's why I like to just match things up. It just makes things really consistent, because it's a safety issue. It really is. And whenever you're working on these, especially an older one, remember that the capacitors that are involved in this can really hold a charge. Fenders are actually any filter cap. I'll say any filter cap can be dangerous, because you're looking at B+. Sometimes it could be 500, 600 volts. Actually, some amps can run as high as 800. And some of the larger caps, like what Marshall uses, and some of the bigger Fender stuff, like for the Dual Showman and Twin, and later on the Basement 300 and stuff, they have massive caps in them. They can retain a charge for days. Unfortunately, I had to figure that out the hard way. I've actually zapped myself with one. So you always want to treat an amp like it's live. Okay, I'll get more on that when we actually start troubleshooting. Not troubleshooting, and when we start going through the voltages on the board when everything's assembled. Okay, so the Deluxe, the Tweed Deluxe, the Mojo 760EX, comes with this red with yellow wire. Now this wire is the center tap for your high voltage secondary. This is a ground reference for your plate voltage on your 6V6s. This is a ground reference for that. And I'll get more into that when we start wiring this up. But this goes to ground. And also, sometimes on these, sometimes on I think we did the Champ for a little bit, might have had a green with a yellow stripe, and the larger 6L6 push-pull amps will have a center tap green with yellow stripe that goes to ground as well. If you notice on the wiring diagram that on this particular amp, there are two 100 ohm resistors right here that go to ground. Well, go to the first cathode resistor, ground, and then ultimately to ground. Now this creates a false center tap for this transformer. What that does is it shunts noise from any AC hum you have in this line to ground itself. Now we'll get more into grounding once we get this all wired up, but that's what those are. Now I've seen some older amps will have the green with yellow to ground. Some of them didn't, some of them did. Marshalls didn't. They usually, well, Marshalls did rather, the bigger ones. The smaller ones like the 18 watts, sometimes they didn't have. They would use the 100 ohm resistors, but they'd be down on the power tube sockets sometimes. And a lot of builders like to put them right down on the power tube sockets. But anyway. Okay, so what I'm going to do is I'm going to wire up. I'm going to start again from left to right at the octal sockets. My rectifier 6V6 is onto the preamps, but with this transformer wiring, I'm only concerned with the wires that are involved in this. And the wires, the reason I do this first is because when you get the board in here, you're going to have wires coming out everywhere. And you'll see once I get that in there, it's best just to go ahead and have these in and out of the way, so you don't need to move any more wiring around to be able to, get these into place and solder them into place, okay? So I'm going to take a break real quick. I'm going to do this, and I'll come back and show you what I came up with.